Hello and welcome to Eris for Developers, blockchain savvy, distilled and concentrated. I am Meher from Validity Labs. This short 20-minute video is an excerpt from our 2-day workshop covering the Eris technology stack. I present to workshop participants the basics of smart contracts and how they relate to traditional financial agreements. We shall also walk through how residential mortgages can be modeled in the blockchain technology paradigm. Let's begin. In this section, we introduce smart contracts, which are financial agreements between economic entities implemented as computer programs running on a blockchain. Smart contracts are a significant innovation which breaks a fundamental underlying assumption behind most accounting systems built over the past half millennia. That invisible assumption is that parties to a transaction are either people or companies. For instance, imagine a normal wire transfer. All of the IT infrastructure built until today assumes that the creator and the receiver of a wire transfer are either individual people or legal entities such as corporations. These might be your neighbor Ben and Walmart, for instance. With blockchain technology, engineers have broken through this assumption. Blockchain designs, such as Eris actually enable a third kind of party to transactions. These third kind of party are executions of programs called smart contracts. Such programs can receive, own, and transfer financial assets. The next few slides will detail some concrete examples. For now, you could imagine the simplest interaction in which I send money to a program. The program has internal code and a set of conditions under which it forwards the same money to another party, such as a bank, 2 days later. So for the first time, we have accounting systems where executions of programs can receive, own, and transfer financial assets. Because these programs live on a blockchain, which is itself maintained by a group of entities, we can create smart contracts that are not owned by anyone in particular. For a concrete example, let's dive into the world of sports betting. A sports bet is fundamentally a financial contract. Two people, such as Angela and Bernhard, decide to partition money based on the outcome of a real-world event, a football match between FC Zurich and FC Basel that takes place after 5 days. This agreement, financial in nature as it impacts their ownership over assets, can be executed in multiple ways. The simplest might be a trusted friend who oversees their bet, holds their money, and then divides the money correctly after observing the outcome of the match. We could also have implemented this as a traditional contract drafted by lawyers representing Angela and Bernhard. Or alternatively, we could fashion this agreement as a computer program executed on an Eris blockchain instance. In the smart contract scenario, a programmer, Catherine, writes a smart contract, a script that can receive, own, and transfer value as an intermediary between Angela and Bernhard. Angela and Bernhard transfer, say, $5 to the smart contract each. The smart contract receives the outcome of the football match after 5 days. Based on its internal code and logic, it sends $10 to Bernhard if FC Basel won and $10 to Angela if FC Zurich did. It is important to note that the smart contract depends on an oracle or data feed to tell it about the result of the football match. So out here we see that a simple financial agreement such as a football bet can be represented as a computer program and executed on a blockchain. For another example, let us explore the use of smart contracts as wills. In principle, wills are easy. They lay out how the assets of a person should be partitioned and distributed when the person is deceased. So you can imagine a smart contract to which the will creator sends her assets. The smart contract, marked in the center of this slide, has instructions that allow it to take information from a local citizen registry and partition the assets of the will creator. The smart contract becomes an extension of the desire of the will creator and neutrally hands over the assets as programmed. In this diagram, the smart contract hands over half the financial assets to inheritor 1 and the other half to inheritor 2. In principle, more complex inheritance patterns can be instantiated by the programmer Catherine. Now I shall demonstrate a simple smart contract in action. Smart contracts are like normal programs and can in theory implement any construct that can be built with other programs. Here we consider Etheria, a decentralized virtual world built using 3 smart contracts. Etheria is actually a simple program with an array of numbers representing land, water, and mountain. This website or explorer fetches the numbers from the Ethereum blockchain and displays it as a virtual world. One can do interesting things on Etheria. Each piece of land can be bought. On the yellow window on the top right corner of the screen, you can see the owners of each piece of land on Etheria when I hover over the particular titles. Users can also buy land on Etheria by inputting a special command into the same program that I demoed earlier, which is get. We shall use software similar to get in our hands-on programming sessions. Etheria demonstrates a different kind of financial transaction. In Etheria, one is essentially paying to change a database entry representing ownership on a blockchain. As an application, Etheria goes to show that smart contracts are really software programs and can be very complex. Any set of operations that can be run on a normal computer can be also run as a smart contract on a blockchain. This is a key idea and will be needed when we discuss ecosystem applications in our next talk. Now that we have a rough idea of what smart contracts are, we shall explore differences between traditional and smart contracts and introduce the concept of dual integration smart contracts. Dual integration smart contracts were invented at Eris Industries and is very powerful technology. We shall use this idea to further build mortgage backed securities. First, we start with an exploration of the difference between traditional legal contracts and smart contracts. One of the major questions is whether smart contracts are a replacement or an augmentation to traditional contracts. The Eris view is that smart contracts are an augmentation to traditional contracts and can provide the execution mechanism of a traditional financial contract. In this field, Nick Szabo, a legal scholar, classified all contracts into 2 categories: wet legal code and dry smart contract code. We shall use this terminology consistently during the workshop. Wet legal code or traditional contracts are interpreted by parties to contracts, law enforcers, and judges. On the other hand, dry smart contract code is interpreted by computers. This difference is pretty fundamental as it results in strengths and limitations for both categories of contracts. For instance, the interpretation of dry smart contract code by computers can lead to inflexibility under unforeseen circumstances. And the interpretation of wet legal code by humans can sometimes resolve unforeseen circumstances through renegotiation, subjective actions done in good faith, or the dispute resolution systems of courts. For an illustration, let's revisit the football match bet between Angela and Bernhard, implemented as a smart contract. Let's say that the oracle or data feed provider does not provide his data input to such a deployed contract. This might be because the company acting as the oracle might have gone bankrupt. In such a scenario, the smart contract potentially just might get stuck if no backups to soccer base are provided for in the code of the contract. The contract has no possibility of handling this situation gracefully if the programmer Catherine has not anticipated this situation and created predefined solutions to the situation. In contrast, if the same bet was fashioned as a traditional legal agreement between Angela and Bernhard, then it leaves open the possibility of them renegotiating on a new data provider or resolving the potential dispute through the justice system. In short, the presence of human interpretation creates much needed flexibility in unforeseen circumstances. Now let us return to the differences between wet code and dry code again. One of the key advantages of smart contract code is the potential for financial process automation and massive scalability. Understanding how smart contracts enable financial process automation is a key item we tackle in the next talk titled Ecosystem Applications: The Motivation Behind the Eris Technology Stack. We can appreciate at this stage, though, that smart contracts, being computer code, can be coded once and deployed across national boundaries in similar scenarios. Like traditional software, smart contracts have the benefit of being super easy to replicate and instantiate thousands of times. This property of easy replication and consistency across national boundaries is quite different from wet legal code, which is generally bespoke, created by highly skilled lawyers and dependent on jurisdictions. For example, a mortgage contract in the jurisdiction of New York State will be different from the one in the City of London. This inhibits standardization and massive scalability. The easy replicability and scalability of smart contracts have the potential to bring low-cost financial agreements to many situations. One of the things that hinder progress in this direction today is that there is very little know-how about the best practices of smart contract programming. On the other hand, societal machinery to handle traditional legal contracts is very widespread in society. This leads to the notion of dual integration smart contracts, which merges traditional agreements and smart contracts in order to create fully fleshed out contracts that are both automatable and enforceable. Dual integration smart contracts are both automatable on a computer, perhaps requiring some human input, and enforceable by traditional legal means such as dispute resolution in the courts. The next couple of slides shall walk through an example of dual integration smart contract. In a later talk, we shall also circulate some documentation and walk through a definitive instantiation of a dual integration smart contract. For now, one can imagine these contracts as containing a traditional contract component that refers to a smart contract component for some parts of its execution mechanism, and a smart contract component that refers to the traditional contract component in certain well-defined or exceptional circumstances. While powerful, dual integration smart contracts are an early stage concept with much of the design thinking evolving continuously. Please exercise appropriate care and refer to legal advice before deploying any of the concepts we sketch out in our workshops into a production system handling real value. Let's walk through a traditional mortgage and how it can be instantiated using dual integration smart contracts. In a mortgage process, a party called a mortgage originator makes loans and transfers money to a home buyer and receives an obligation from the home buyer for monthly payments with predefined timing and amount conditions. In this example slide, we sketch a mortgage with a principal amount of $1 million and monthly payments of $4,500 per month for a period of 30 years. This corresponds to a 3.5% fixed interest rate. Some examples of mortgage companies from across the world are presented. These are Syndeo in the United States, the Hong Kong Mortgage Corporation Limited in Hong Kong, and Halifax in England. Mortgage contracts can be imagined as having two potential future states. In state 1, the homeowner is paying monthly installments correctly, and in state 2, the homeowner stops paying monthly installments on time. We shall call state 1 the normal operation mode and state 2 the default operation mode. In the default operation mode, mortgage originators have the right to claim the home as own property. This party can then proceed to auction off the home and recover part of the principal amount. This process is called foreclosure. While foreclosure is an available option, sometimes it is best for the mortgage originator to renegotiate a new agreement with the homeowner instead. This new agreement might stipulate a lower interest rate or a longer payback horizon or other clauses. These sorts of renegotiations can enable the mortgage originator to realize other synergies such as preserving an existing customer, savings on foreclosure costs, administrative costs, or wait for the home prices to appreciate. Therefore, the best decision for the mortgage originator in default operation mode requires the exercise of human subjectivity in making an optimal choice. On the other hand, the normal operation mode with monthly payments flowing in smoothly requires no exercise of human subjectivity and therefore can be handled by computer code in the form of a traditional smart contract. It is this combination that a disk mortgage allows us to instantiate. From now on, disk stands for Dual Integration Smart Contract. Let us walk through some additional details of a disk mortgage. Traditional mortgage agreements have multiple subcontracts that refer to each other in order to constitute a unit. Mortgage agreements vary in their specification depending on state and national jurisdictional boundaries. The example taken here is just indicative and may not correspond 100% to any particular jurisdiction. Some of the important subcontracts in a traditional mortgage are a document laying out the general terms of the loan agreement between the mortgage originator and the homeowner, a collateral security agreement which results in the mortgage originator obtaining a lien on the property owned by the homeowner, and a promissory note in which the homeowner promises to pay a determinate sum of money either at a fixed or determinable future time to the holder of the promissory note. The promissory note has the special property that it can be handed over from one party to another. Any party that holds the promissory note in the future can claim money from the issuer of the promissory note. In our case, the issuer of the promissory note is the homeowner. Later, we shall present physical copies of the combination of these three documents so you can review how they connect with each other. Disk mortgages improve upon the current state by adding a fourth smart contract component that takes over some of the role of the promissory note and enables additional functionality leading to financial automation. The smart contract lives on a blockchain and has a defined address, indicated by the ID on top of the right-hand side of this diagram. The smart contract component has internal tokens representing ownership over the promissory notes. The general terms of the agreement then direct the homeowner to make monthly payments to the smart contract with a particular ID on a particular blockchain in a predefined unit of value. This creates a linkage between general terms and the smart contract. The second leg of this integration is that smart contract has internal mathematical logic that allows it to track if the homeowner is making payments on time in full. Should this stop happening, it enters the default operation mode where a particular internal Boolean variable switches from false to true. In this scenario, the mortgage originator can use the collateral security agreement to foreclose on the homeowner. Thus, traditional legal contracts are referring to and are being referred to by smart contracts in order to form dual integration smart contracts. As you can see, this construct of mixing both traditional and smart contracts enables the exercise of human subjectivity in certain situations and enables financial process automation in others. Therefore, as contract builders, we can avail the best of both worlds. As a summary, a disk mortgage has two states, the normal operation mode and the default operation mode. The normal operation mode, with its benefit of financial process automation, is marked by and can be distinguished by the value of a particular variable stored inside the smart contract. We shall call it default underscore state underscore variable, and it's set to false in normal operation. On the other hand, in the default operation mode, with its benefit of exercise of human subjectivity to renegotiate or foreclosed, is marked by the same variable called default underscore state underscore variable having a value of true. We shall take forward this theme of disk mortgages developed in this talk forward throughout the workshop. That brings us to the end of this short video excerpt. This excerpt is part of the 2-day workshop Eris for Developers, designed and hosted by Validity Labs. This workshop is officially endorsed by Eris Industries. Thank you for taking out the time to check out the video. Do drop us a note at the indicated touch points if this workshop is of interest to you. Thank you and talk to you soon.